The transactional outbox pattern is a design pattern that could be used to ensure data consistency among different services. In this pattern, instead of directly calling other services or sending messages to the message broker as part of the local transaction, we first insert a new message into the database table called outbox, and then send it to the other services using a separate process called outbox processor. For example, when we create a new building in our current system, we first insert a new building into the database and then create a new workflow for this building by calling the workflows service. With the transactional outbox pattern, instead of calling the workflows service, we would insert a new record to the outbox table as part of the local database transaction that represents a task, which eventually we'll call this service. Lastly, we would need a background job or process called outbox processor that would periodically check the outbox table for new messages and send them to the message broker. Don't worry if all of this sounds a bit confusing at this point. Things will become much clearer once we implement this pattern in our application in just a moment. Okay, so let's start things off by creating a new outbox module in the virtual facility project. Note that instead of generating this module in the virtual facility, we could technically generate it in the libs folder, making it available to all other applications in our Mono repo. It is very likely that we may end up needing this functionality in other applications after all. As an exercise, try to generate a new library yourself and move the outbox module there. Next, let's create a new outbox entity with a few columns in the outbox module. And next, let's generate a new outbox service file in the outbox module as well. Once the file is generated, let's inject the outbox repository provider using the inject repository decorator. Next, let's declare a new getUnprocessed messages method that will return all unprocessed messages. This method here takes an options parameter that lets us filter messages by the target service. Also, all messages are sorted by the created@at column in ascending order. Let's save our changes and open up the outbox module file. Let's import the typeorm module for feature method and pass the outbox entity to it. Also, we'll need the workflows service client available in the context of this module. So let's import the clients module and supply the workflows service configuration there. Great. Note that registering this provider here effectively means that we'll have two different client instances for the workflows service. One provided in the buildings module file and one provided in the outbox module file. Ideally, we'd create a new module that will be responsible for providing the workflow service client, but for simplicity's sake, we'll leave it as is for now. Now that we have the outbox module in place, let's open up the building service file and inject the data source provider using the standard approach. Next, let's scroll down to the create method and update the code to initialize the transaction. With the transaction initialized, let's retrieve the buildings repository from the query runner object. Also, let's retrieve the outbox repository so we can insert a new message into the outbox table. Let's wrap everything up in a try-catch block and roll back the transaction if an error occurs. Otherwise, let's commit the transaction. Now, using our local buildings repository, let's insert a new building into the database. Afterwards, let's insert a new message into the outbox table. Perfect. Now, whenever we create a new building, we'll also insert a new message into that outbox table. If the transaction fails, the message won't be inserted, and so it will be never sent to the workflows service. The last remaining step we have is to create a new background job or process called the outbox processor. This processor will periodically check the outbox table for new messages and send them to the message broker if any are found. We could also listen to the Postgres events to trigger the sending process, but for simplicity's sake, we'll use a simple cron-based approach in this course. Just know that you have multiple choices for options here on how to handle this. So let's create a new Outbox Processor TS file in the Outbox module with the following content. With all of our needed dependencies injected, let's declare a new dispatch workflow event method that will send a new event to our workflows service. Inside this process Outbox messages method, let's retrieve all unprocessed messages from our Outbox table. Next, let's iterate over the messages and send them to our message broker. And last but not least, let's register the Outbox Processor provider in the Outbox module file. Also, let's not forget to import the schedule module in the app module file so that our background job or process can be executed properly. Let's save our changes, and before we test everything out, let's make sure we also update the Workflows Create message handler to use the Event Pattern Decorator instead of the Message Pattern Decorator, since we're now using the emit method to send events to the Workflows service. Let's save our changes here and head over to the terminal and make sure everything is up and running. If you're seeing any errors, just double check that you followed all the steps we just covered. If the application is up and running smoothly, let's create a new building using curl to test everything out. Now, let's wait a little bit. And as we can see, there's that created workflow log message, which means that our workflow service successfully received the Workflows Create event. Fantastic. Everything's working great. Before we wrap up in this lesson, let's speed things up a little bit by leveraging TypoRM's entity subscribers. As we mentioned at the beginning of this lesson, we could listen to the Postgres events to trigger this sending process. Basically, whenever a new Outbox record is inserted, Postgres would emit an event instructing our application to send the message to the message broker. With TypoRM, we can achieve a somewhat similar functionality by using entity subscribers. However, please note that this approach might not be suitable for all use cases. If you'd rather process messages in batches, you should stick to the cron-based approach. We'll just showcase this option as it might be suitable for some use cases and applications out there. Okay, so to begin with the entity subscriber approach, let's create a new Outbox entity subscriber TS file in the Outbox module with the following content. Let's break this class down so everything makes much more sense. First, we're adding this class to the data source subscribers array so that it can listen to entity events. The listen to method indicates which entities this subscriber is interested in. Lastly, the after insert method is called after the entity is inserted into the database. In this method, you may have noticed that we also immediately dispatch the message to the message broker. Now, with this class in place, let's open up the Outbox module file and register the Outbox entity subscriber class as a provider. Let's save our changes and head over to the terminal and make sure everything is still up and running. If so, let's again create a new building using curl. Now, let's switch back to our terminal and look at the logs once more. As we can see, a new workflow was created almost immediately after the building was created now. It worked. So, to summarize, in this lesson, we learned how to use the transactional Outbox pattern to ensure data consistency among different services. This pattern is particularly useful when we can't afford to lose messages and we need to make sure that they are eventually delivered to the consumer service, hence achieving the so-called at least once delivery guarantee. Before we finish, let's focus on one little caveat you might have thought about already. What if after sending a message to the Workflows service, the Outbox processor process crashes before removing the message from the database? In this case, when the application recovers, the message will be sent again, and obviously we wouldn't want that. This is why the Outbox pattern lets us achieve at least once delivery guarantee, not exactly once delivery. In other words, we can't guarantee that the message will be delivered exactly once, but we can guarantee that it will reach the destination at least once. We'll talk more about this predicament in the next lesson.